nearby traffic lights. And crowd-sourced data, where they are going to use the mobile apps like the parking or navigation apps. They provide additional insights into traffic flow. For example, if a road segment has unusual congestion, the system detects it instantly instead of waiting for human monitoring. Next is your connectivity and IoT infrastructure. So wireless communication is being used. So traffic signals are connected through 4G or 5G and municipal fiber optic networks and IoT gateways. So each traffic light is connected to the city's UMCC, that is Urban Mobility Control Center, via this IoT gateways. And real-time data flow. So data is constantly streamed to centralized servers. So a bus approaching a junction generally sends a signal via this IoT. The system immediately adjusts the light sequence. Then what is AI and decision making? So AI means nothing but here it is trying to take the adaptive in nature, means adaptive algorithms can be applied. So it analyzes the congestion, the peak hours, predicts the peak hours and reconfigure the light timings dynamically. Predictive analytics means the historical data helps which forecasts the traffic surges, like whenever there is a football match or a festival season, at that time it is trying to predict the historical data. Based on the historical data, it is predicting whether there will be more traffic or not. Coming to the emergency routing, AI ensures the emergency vehicles have green corridor by turning the lights green all along their complete path. So making them to pass or give priority to them. That is, during rush hours, lights stay green longer on busier avenues but shorter on side streets. Then how it is integrated with public transport, means all your vehicles, how it is going to be integrated. So bus or any tram priority systems, so these vehicles transmit their location. Nearby lights extend the green time or shorten red. And smart scheduling means, for example, the metro or any tram, that is timetables of that are linked with the road signals to smoothen the flow of traffic. So faster public transport, encouraging the citizens to use it over private cars. Coming to the pedestrians and cyclists, how it is friendly in nature. So smart crosswalks. So crosswalks, so for example, if pedestrian or any elderly people trying to cross the road, so in that situation, they will be given the more priority. So pressure sensors are there or smartphone apps are there. They detect the persons, pedestrians or any say elderly people and who are waiting to cross the road. They give the priority and then like making the light green so that they can move. Adaptive signals. So longer crossing times for elderly or disabled individuals. Bike lanes. So bike lanes with sensors also there in this particular country, where you can see the traffic lights recognizes who is approaching or the person, the cyclist who is approaching, and it adjusts accordingly. And an elderly person, when he carries a smart card, it can automatically trigger extending the crossing time. Coming to the data platforms and governance. So UMCC is nothing but the central place where everything is going to be monitored by this center. So city's control room where real-time dashboards monitor all the traffic. Open data sharing. So this country shares the traffic data with the app developers like Google Maps or something called Waze. Citizen engagement. So residents can access live updates using this particular apps, showing where there is congestion, parking and traffic lights, everything. So more transparency and improved planning for both citizens as well as the policymakers. Environmental integration. So emission reduction strategy. So light reduce vehicle idling, means more the time you need not stay idle. So that is going to be reduced with the help of this traffic system, whereas CO2 output is also, carbon dioxide is lowered. Green transport incentives. So both like electric vehicles or hybrid vehicles given more priority at intersections compared to the other vehicles. Data-driven urban planning. So collected data is used to redesign the streets, create low emission zones and expand the cycling paths. So these now we will discuss like what are the challenges in urban life, what are the different challenges. So we will be seeing across traffic congestion, energy waste, slow public services, pollution, health risks, safety, emergency response gap. So traffic congestion. So example, the country USA, in which the Los Angeles implemented AI-driven traffic management systems, which is trying to traffic management system that is trying to adjust the signal timings based on the vehicle flow patterns, reducing commute times and lowering emissions. So traffic congestion. So this country has proper handling of traffic congestion. So that is one of the challenge in urban areas. Energy waste. So this Netherlands. AI systems in Amsterdam analyze the energy consumption data from buildings and recommend energy saving measures. So they use smart grids, also allow for better balancing of renewable energy sources. Coming to slow public services. So something in South Korea, Seoul, waste collection system. Waste collection system uses this AI powered route optimization, ensuring that garbage trucks operate efficiently and reduce fuel consumption. Coming to the pollution and health risks in China. In China, the Beijing, we observe that the AI monitors air pollution levels in real time and alert the citizens, while also helping the government authorities forecast the pollution spikes and enforce regulations. Coming to the safety and emergency response in New York City, USA, AI analyzes the video feeds from surveillance cameras to detect any unusual activities are going on or any potential threats are there, allowing the faster law enforcement responses. So some of the case studies, like different countries, how they have been using this smart cities or how they have been implemented the smart cities. So the one country is Songdo, which is state Songdo of South Korea, fully integrated smart city where everything, transportation, waste management, energy usage and even healthcare is monitored and optimized in real time. AI algorithms help plan the urban spaces, reduce the carbon emissions, manage the resources dynamically, offering a blueprint for future cities. And in Dubai also they use sensors in infrastructure like bridges and roads. Feed real-time data into the AI system to predict the maintenance needs before the damage occurs. Before the damage occurs, we try to maintain all the information so that they can predict if anything is going to be in a wrong direction. They are going to predict before only. That is predictive maintenance. That is your data science is trying to be implemented here. So public safety in London. It analyzes the crime patterns, helping the police deploy the resources more efficiently and prevent the crimes. Coming to the healthcare, So in Canada, AI systems will track the patient data across the hospitals to predict outbreaks and improve the emergency room workflows. So with the help of these all case studies, we can also come up with new ideas where we can implement this AI and data science, or use AI and data science to make our India also a smarter city. And like we can come up with good projects in different areas and give some suggestions to the students in these different areas where we can make our cities a smart city. So coming to the first one, traffic and urban mobility. So first we try to collect the data, that is through GPS devices, CCTV cameras, sensors, mobile apps. So there are 4 different ways you can have the data collection. So vehicles and smartphones continuously send the location data, helping track movement patterns and congestion. And coming to CCTV cameras, they are installed at intersections and roadsides. These cameras monitor vehicle flow, traffic violations, and pedestrian activity. These have been implemented in, Spain. That is Barcelona state of Spain. It has been implemented. So sensors have been used that are embedded in roads or along the pathways. These devices detect the vehicle presence, speed, and environmental factors such as air quality. Mobile apps like Google Maps or Waze or local transport apps crowdsource traffic data and offer real-time updates to the users. So by combining all these data sources, AI can analyze the traffic density, predict the delays, and plan for smoother urban movement. So prediction and planning. So AI helps cities forecast traffic conditions and plan better routes, improving the commute times and reducing congestion. So from office to home to office, how you can reduce your or optimize your routes or reduce the congestion. So traffic forecasting, where we can see, or it uses the historical traffic patterns and current data to predict the congestion before it happens. So what are the different AI models which we are using in this prediction and planning is something called LSTM and ARIMA. So LSTM stands for long short-term memory. It is a variant of recurrent neural networks. Similarly, ARIMA, which help to anticipate the traffic buildups at specific times of the day or due to events like accidents or construction work. So enables cities to prepare alternative routes or inform the commuters in advance. So for example, if we say LSTM, it is generally used for time series data. So time series means which changes over time. So for sequential data, it is being designed. It remembers the past patterns and uses them to predict the future. So it is trying to remember what the past patterns it has been observed throughout the day. Based on that, it is trying to predict the future. Next, unlike the normal neural networks, they have a memory cell. That memory cell is important for storing these long-term dependencies. This is one of the deep learning subject concept, that is LSTM. Similarly, there is something called ARIMA, auto-regressive integrated moving average. So it is also observes or identifies the traffic patterns. ARIMA is a statistical model which is used to analyze and forecast the data. It works best when traffic shows regular patterns like rush hours. During that particular time, it tries to give the best results. Coming to the route optimization. So route optimization, here we use something called Distrust or A-star algorithms. They calculate the shortest and fastest routes based on real-time traffic data. It helps help the logistic companies, public transport systems, and everyday commuters avoid delays and minimize fuel consumption. And it also is adaptive routing. Adaptive routing means like based on the real time traffic, it tries to go for a different path or smallest path or the best path it is trying to choose. Temporary obstacles are there, then it is trying to go for a different alternative path whenever our road closures or weather conditions take place. Coming to the real-time control, AI systems don't just plan ahead, they actively manage the traffic as situations evolve. So adaptive signal control. So traffic lights adjust in real time based on the traffic flow. For example, signal can extend green phases for emergency vehicles or for smart crossing the roads. So in that situation, it will try to extend the green color. In this, what type of algorithms